Hello, welcome to AUTOMAT Live-Coding. This is the stream where we write AUTOMAT, an application for automated game input. It's for game macros. If you have some grind-heavy game, you can use AUTOMAT to automatically send keyboard events, type something. We seem to have some issues. Plenty of them, actually. Anyway, we are still developing it. Look, that was a nice shader, wasn't it? We're still developing it, so yeah, I really like it. So today we are going to fix the clipping issues. One of them actually you've seen right here. Because right now when we render an object, we only render a part of a texture. And then when I can show this, when I move the window to this side, we don't have the full object rendered. So instead we are rendering this ghost of an object. Those are examples. And there we go. So this is an example of us using old textures to render a kind of temporary ghost image. This is supposed to be temporary. So this stuff, I think when I zoom in and out, we should get a better FPS. Actually, the FPS is kind of bad right now. I wonder why. And we even have crashes. Okay, so the point for today is to fix the clipping issues. We will resolve the crashes as well. So, but afterwards. Tiny action item. Okay, let's fire off VS Code. Let's start with clipping of the top part of the window. So actually the thing is that this is something that can be seen when we enable debug mode for rendering. We have to recompile everything. This is a header change. Okay, so we have this rainbow line around the window, And this rainbow line should have 2 pixels, exactly 2 pixels. On the top side of the window, however, it only has 1 pixel. And when I move, you can see that this texture, this should be clipped to the size of the window. Oops. I moved it, but from the right and left and bottom, it seems that it is properly clipped, but not from the top. From the top, it seems it's exactly twice as high as it should be. I think this is the bounds of the machine object. Let's investigate this. Okay, render frame. This is the function we are interested in. This is the function that I think should do the clipping. It starts with pack frame. Okay, this is irrelevant. Step 2 is the important one. Okay, let's look some stuff. So widget is a shared pointer. And root machine is also a shared pointer. I just want to see if this if condition works. Okay, it seems it does. Okay, those are the bounds of the root machine. This looks good. And in this variable, we seem to be holding the bounds in the pixel coordinates. Let's try to print them root bounds. And they look reasonable. I think if I unzoom, for instance, so that the whole machine fits on screen, now the top, right, bottom and left, yeah, they look like reasonable pixel coordinates. Looks good so far. So here we are checking if the object is small enough. If it's small enough, we will render the full extent of the object. Here we do the clipping. Maybe those window bounds are wrong, let's see. Okay, they are wrong. Because the window is not a rectangle. Yeah, that was the issue. Incredible. Yeah, now we get proper clipping from the top as well. Okay, and this we will keep for ourselves. Now, let's take care of this redrawing objects when we pan. I think this is going to be the same place. I think somewhere here we should check what are the bounds of the object last time and what are the bounds of the object right now. After an object is rendered, we are storing its coordinates in this variable. I don't really care about root bounds of the object, but after this clipping happens, I think I should do a similar transform window to local. Is it initialized? Yes, it is. Probably rename this, but those are the new surface bounds of the object. I mean, so this is the part of the object that is visible. Maybe I should use root bounds for that actually. So the clipping happens in the window coordinate system, then we go back from the window coordinate system to the local one. So this is the visible chunk of the object. Now I would like to compare this with the stuff that we have in texture. And this is what we have here. Let's add another method here. Actually, this should be opposite. And this is just an alias, just to have a more informative name. Okay, it seems that within the node we have some booleans and we still have some padding that we could use here. So this we will set to true if the currently rendered texture is reusable for the current frame. Blah, blah, blah. So here. So at this point we cannot yet assign a verdict because it's possible that some of the objects, some of the widgets which are down the hierarchy could still be animating. So we cannot say just to use this texture. We need to combine it with the further parts of the analysis. I think this is the place. Let's see. I don't know why we got 3 timelines. But look, this is properly re-rendered now. If I pause it and scroll, cool. Honestly, it's good that we are not seeing any of the flipping, apparently, anymore. Cool. Honestly, I'm suspicious. I expected more complications on the way. Okay, we see some of the noise on the edges of the screen when I unzoom. See, this is where the new texture is being re-rendered. Things seem to work smoothly. Let's submit it. So that was the next point on the roadmap. Next we have this issue with the timeline placement. But before I do that, let me take a short break. We'll be right back.
Tobion364 says,
Oh, Chair the Programmer are my favorite.
All right. Honestly, I will have probably plenty of time today, so I actually wonder what we could implement. There are some important quality of life fixes. Maybe we can do those. Okay, let's start with the placement of the timeline, because we cannot accept a broken micro recording. Okay, so I put a macro recorder, I press a space, press and release. Okay, press and release. That was so weird. And this A object, it was rendered with quite a delay. I wonder why. So we have this find or create timeline. Okay, so this could be the issue. So when we search for a nearby object, for an existing location, we're only checking the list, the outgoing list. Okay, so this is one important place for us to work on. This outgoing list, we need to update it after we create a new it looks like we are doing this already. Update auto-connect args. Maybe this is the issue. We've been doing some changes to coordinate. Yes, this transform between. Yeah, I think this is it. We probably are messing something with the coordinates. Almost sure. Okay, these nearby candidates may be broken. Okay, this seems wrong. Come on. Again, we don't want to use stuff like that. we want to use transform between. This may also be wrong. Let's see if this helped what we've done, because maybe the error is here. It's interesting that we have a couple different approaches and each of them works differently. So we have to unify those three things. This thick connection, the thin line that appears when I drag the macro recorder, and there is also the moment where we establish and lose connection, which seems to be also wrong. Oh, this is weird. Target object's local coordinate space. So if I understand this correctly, we should not be doing this. Seems to work now. Or not. Okay, we have a nice crash. Let's try debug mode. Because we can hit two birds with one stone. This is oh no, we actually had a breakpoint here. We can continue. So I delete this, I click record, and I press a button. And then now we get a crash. Okay, this looks like Stack Overflow. How does this go? I should really remove this lambda nesting. C++ wasn't, I mean, it can do lambdas, but it's not great at that. The stack traces are awful. If I could just remove this from the stack trace, I would be fine with lambdas. But we can switch to iterators. Okay. So we are in this DFS. Okay, this is not Stack Overflow. This is just a regular. This is actually a regular stack. It's just full of lambda related noise. Okay, this is something we will be able to fix later. Okay, we have this update path. Cool. So when we are inside some pointer method, anyway, newly created timeline, has a broken widget parent chain. Parent is null pointer. I actually wonder, in the create, don't we call fixed parents? Yeah, we do. I think I know. Timeline has a very specific button. This is a toggle button that can switch its widgets. So when it's created, it's not in the recording state. So it returns, I don't know, this widget probably. Should be able to do... No, we will not. Okay. This one, and not this one, so it must be let's do different cast library. This is the one. I think we should change this to virtual. First of all, toggle button should also override it. Huh. After activate. No, it still doesn't work. But okay, the thin line and thick line, they work nicely. So I know that the issue is probably not Now it works. So it seems like only the only the newly created timeline has issues. Yeah, when I move the object, it fixes itself. Yeah, works fine. This also works fine. One more attempt. Yeah. A newly created timeline for some reason for a very short period after being created, it has issues. Okay, maybe this is the issue. Position below. Oh, this is not a position, this is index. I think this is a place where we could add some logs. Or maybe an assert. This is the issue. Right after we create a new object, it should be immediately connected. I could do this, and we could do step-by-step debugging to see what's going on. Let's do that. It's amazing that this is debug mode. And this debug mode still works so fast. I mean, we have artifacts, but those are artifacts that we added deliberately, like pixelation or the choppy animation. So this object animates at a very slow speed, but the response time of the application is much lower. Anyway, we wanted to debug some stuff, so let's try doing that. So here we start. We are entering this function, we created a new timeline, and then now we want to update the connections of the macro recorder. Step in. Let me fix the gamma because I guess the screen must be kind of dark. Did I lose music? What happened? Something weird. VLC stopped working. Let me see. Do I get any sound from this system now? I think my PC is having some issues. I guess I will have to reboot. Yeah, I will just reboot. This is probably a sign.
Something like that. But then it just was so much punch.
It started to work. And there it's back. Weird. So debugging one application blocked others from playing audio. But only after I updated xrender. Huh. Anyway, stuff fixed itself, so let's continue. Okay, so this is the position where we created the timeline. Minus 17 centimeters, 7 centimeters. So the origin should be around there. Actually, let's... Actually, that looks fine. Let me delete all of those. Stop. And what's that? Okay, let's just restart. That was another bug, maybe also worth looking at, but let's focus on the first one. I would like to position it so that it creates the timeline at... Actually, that wasn't a bad position, at minus 10 centimeters. Something like that. Minus 20? Yeah, minus 20, yeah. Step in. Okay, this is a lambda function, so we have to step in to see what's going on. Or I can also set up a breakpoint here, continue, and disable the breakpoint. Okay, argument has autoconnect radius of 0. Okay, because this is the next argument, so this is not what we are interested in. Okay, that was interesting. So we only had one argument. Let's step in, step over. So this is our timeline, right? And when we ask it for the list of arguments, we get the first argument called next, which is an optional. It has autoconnect radius of 0. And that's it. Okay, the timeline should have arcs function here. Sorry, not timeline. Let's run this again. Let's run this again. Because timeline has no arguments, this is right. But nearby objects have... Oh, come on. Okay, restart. Only updates arguments of the other locations and their arguments. Okay, so this is actually totally irrelevant. So step over, step over, step over. the issue must be here, somewhere here. I wonder about this matrix. Okay, this is a unit matrix still. That's strange. This is super strange. This matrix is wrong. Here up is wrong. Okay, the object has a parent. This, and this is the location. The location has a parent, it's the machine. So this transform between. Why did it return a unit matrix? Let's restart this. Let's try again. Oh, come on. I don't care about that. Step into, step over, step over, step over, step into. Okay, which of those matrices? I mean, they are both one. But up is the important one. The up should not be a unit matrix. Okay, the matrix is... Actually, it has some funny values. But anyway, this parent transform to child. Okay, let's go back to this. So this is the position of the timeline location. This center looks a little bit off, but I guess it's not a big deal.
Mehad just followed on Twitch.
Hey, thanks for the follow. This is what we do most of the time on this stream. We're just trying to debug matrix transformations. I never really understood the role of these post and pre operations.
Mehad for 12 says,
Where is Python?
We do have Python. All of our built infrastructure is in Python, and this is all custom built infra. Oh, and if you're a Python fan, we also have a nice project coming up. So we're doing this environment for automating macros. Visual mostly, it's mostly block-based. The thing is that whenever you need a more complex logic, we'll have like a built-in Python environment. This is one of the major projects that we are probably going to do after we fix the core functions. But it's coming up, it's coming up. I think we're months away though. Okay, scale. Initial scale apparently is 0. Good. But the position is also 0. Okay. Okay, so this is why we did not connect. Because a newly created object, a newly created location Let's load more stack frames. This is probably what we should do first. Okay, let's try that. Let's try reordering this code. Disable this breakpoint and restart everything.
Can you explain what you are doing, please?
Sure. I will just stop debugging and run a release mode because this is just terribly slow. So here is, do you know Incredible Machine, the game? So this is a game where you build a machine out of some random toys. The idea comes from comics by Rube Goldberg. There is also this Rube Goldberg machine. The guy came out with those kind of machines. So here we are applying the Rube Goldberg architecture to application. So this is a program that can automate. This is a macro playback machine. I can record some key presses, for example AD, and when I play them back, they can actually, send input, and we can connect them into chains. So here is a timer that this is a loop, right? This is a loop with a period of, for instance, half a second. So we have this environment where we can build automations that will do stuff. And if we want, we can also change this so that instead of pressing the D key, it will press the mouse button. Then we will wait for half a second, and then we will release it. Right? So now I have a macro that will press a mouse button for half a second. And if I run this and I move my mouse here on the top, on the title bar, it actually did press the mouse button for half a second. So this is an environment for building desktop automations out of smaller machines. However, we are still in development phase, so most of the stream we are doing heavy debugging.
Thank you, that looked good. What is name is Major?
This is called AUTOMAT. I'm not sure I correctly understood your question. The name of the project is AUTOMAT, and it has a website at automat.org with some videos. And it can be downloaded, although I guess the version from GitHub is kind of broken because, yeah. Okay, it seems we fixed the bug. how a newly created object, a newly created timeline properly registers keys immediately. Okay, I think we have to leave a comment about this. This is actually a very strange behavior that we had just now. So this is green. Let's do an arrow here because we don't need an arrow. We need to document this because this is so strange. What just happened? So the fix was actually very simple. The fix was to just swap the order of some lines. But okay, here. No, not here. We need to go to the header. Hey! Hello back, long time no see. Yeah. And what was that sound? So the story starts like a horror movie. Okay, I cannot wait for the reveal. So what was that? So you didn't find out what was the thing making noises? It just disappeared. Maybe you have somebody living in the attic, like very large mice. Okay, honestly I would be scared at this point. So this is what we will do now. I want to get rid of all the lambdas. I'll be right back. Short break. This is common, I also got to those. When I was a kid, when I was small, I was like afraid of being alone in the dark. I sometimes even felt as if somebody touched me from behind. Like, being a kid is scary. I'm so happy that those things, they must be somehow kind of built into our psychology, those fears. At some point they just went away. Yeah, nowadays I can go through the forest at night without light and it's chill, it's peaceful. And when I was like younger, it was terrifying. Okay, turn visit children into an iterator. This is going to be a big change. Yeah. Good point. Okay, so this is roughly the same thing that we want to have. We want to create an iterator. Unlikely. So Ukraine is not really going after Russian territory. There are plenty of people who understand that within Russia. It would be obvious to everybody that the atomic weapons are used offensively and not defensively. So, no, I don't think there is. I mean, of course, there is always some possibility, but it's not realistic. What did I do? I need to close this. Some things about C++ are messed up. Yeah. It's also a part of kind of Russian national identity that they never used nuclear weapons. And, you know, it all boils down to the people at the top and their motivations. They seem to be mostly interested in kind of growing the, quote, Russian Empire and kind of recording themselves on the history, in history books. And using nuclear weapons would go against that. They would kind of... So first of all, they would lose the war if they did that. but their goal of kind of growing the Russian Empire, yeah, it would break everything for them. Poland's actually very similar to Ukraine in terms of kind of how much fight it can put up. The big difference is that we have plenty of allies. We have been lucky to join NATO like 20 years ago. So by now the country is very much integrated already. Yeah, that's true. Poland has a very good history of wars against Russia, but it's just a history. It can go either way. So revenge is not a good kind of goal here. Not for like a conflict. And nobody's even like thinking of having war just to have a revenge. Yeah, I think so. The ideal solution would be if Russia just stopped the war. If they just stopped the war, if they became like a democratic society without these imperialist, like expansionist plans, yeah, that would be perfect. Nobody wants to have revenge on anybody. It's just, it would be so nice if they didn't do that.
Prefer to deeply understand every detail of a library by studying its full documentation? Or would you rather learn by experimenting with the basics and starting a project to apply what you've learned?
This is actually a great question. It applies not only to libraries but also to like languages, to any piece of technology. And you framed the question very nicely because you kind of listed the different strategies there. So you in your question, I see 3 different strategies. You first mentioned like studying the documentation, experimenting with, like the basics, and then project-oriented learning approach. And out of those 3, the first 2 are the best for learning. So as you are reading the documentation, my strategy is to write small toy applications to experiment with the new library or a new language or a new piece of technology. And when I learn of a new property of this library, I try to push it to the maximum and see where it breaks. For example, performance, what's the bottleneck? Or can it handle like different like malformed data and this kind of stuff. And project-oriented approach, I actually don't use this for learning at all. This project-oriented approach has the problem that you want to get some effect, you want to achieve some kind of objective, but then when you start using libraries, you always have a bunch of roadblocks. And getting over those roadblocks it's very random. The more time you spend trying, the higher the chances, but it can burn you out. It's very easy to get burnt out by doing project-oriented learning. It's very exhausting. It's not super fun. So a lot of the kind of... I think it's common, for example, to start programming by writing a game. It's... initially it's very good because it's very easy to kind of get initial motivation, but once you hit some issues, then this approach doesn't work so great. Yeah, I knew people just like him. I'm answering to you, Nexus, now. When I used to work at Google, he's like the perfect project manager guy. He's very active, he cares, very charismatic. This is like some of the most important qualities of like a good project manager. Yeah, quite likely. Okay. The stuff that I'm looking at here is I'm kind of trying to convert a lambda call into a flat iterator. I have to remove const, that's fine. How do I convert from lambda to this? I could run this in a coroutine. Let me check. Who's Jake, bro? Yeah. I don't know to kind of enter this rabbit hole. It's a deep one. We should probably focus on doing other things. Whoa, this is amazing. Thanks for the kind words. My TTS broke. I try to fix this. Roses and sins. The cable. I think the cable will still glitch if we run it in debug mode. So we introduced a bunch of mechanisms to help with slow and unreliable execution. So when we are rendering stuff, we are trying to render stuff in the background. So I will create a timeline with a bunch of objects connected with cables. So for instance, now when I have those cables, you can see that they actually render very slowly at a couple FPS, but we are deforming the textures so that the deformation is also not perfect, but it means that we can move the object relatively fast, even though the cables update very rarely, and that they have performance issues still. So this is a debug mode. In debug mode, there is no caching, so the cable issues kind of constantly appear. But the issue with the cables was that each cable is actually compiling a shader on every frame, and it's doing the MIP mapping of this texture, and this is a large texture. But this is just a problem of the debug mode. In release mode, caching works properly. So, but when we've been developing the debug mode, we introduced so many of those features that, like, the performance is just acceptable now, even when we are doing debugging. When just a single object is being moved, it's even more responsive. So we have a couple like other mechanisms. So when I, for example, unzoom, you can see those ghost images around. This is because we are trying to fill the part of the screen which wasn't yet rendered with current texture. So we have this glitchy TV effect. This is deliberate, by the way. This is not an error. This effect, these wavy, noisy images. We also have a pixelation effect. So when we zoom in very quickly, we are reusing the old low-resolution texture by just remapping it to the new coordinates. And we have the choppy animation. So when there are a lot of things to render, they render in this, like, for example, one every couple of frames. So if something's rendering slowly, it doesn't drag the whole system down. So there is like a bunch of mechanisms. They only activate in debug mode though, because we fixed all of the issues in release. In release mode, we also have those mechanisms, but they are barely visible. So for instance, when I'm here, when I quickly unzoom, you will see at the edges of the screen, we will see the noise. But it's like just a fraction, like a couple pixels at the edge of the screen, with noisy, kind of noisy shader trying to kind of guess what is going to be here. When I unzoom and zoom in quickly, you may also see pixelation, but also just barely. If I create maybe like a ton of parrots, I mean, not even that, maybe a ton of timelines. Yeah, the performance issues are mostly gone now. Still have some bugs, but we're slowly fixing them. Okay. Hopefully TTS should work now. Yeah, today I fixed a couple of bugs. That was my plan for today. We've done this in less than an hour. So now I'm doing the code cleanups. For example, converting some of the ugly lambdas into much nicer iterators. Okay, so this is a very simple adapter. This children view, which just calls the lambda, it copies everything into this. It's terrible, it's inefficient, but this is just for the transition. So recently I'm playing Factorio. And it's amazing. A Factorio Space Age. A little bit. I used to have, let me see my Factorio. I used to play Space Exploration actually. That was a mod, like a very large mod that was the inspiration for Space Age. You know, the reason you get so many hours, like people get so many hours in Factorio, is because they leave it overnight. It's not because they literally spend months in the game, but it's just when you leave the factory overnight, it can kind of produce, stabilize. So this is why this game has amplified. It has very high hours played. So I use plenty of mods. But those are just the kind of most popular ones. Yeah. Okay, so this is my adapter. I wonder if this works. I think I also need a comparison operator with an iterator. Get rid of this part. And I don't really need to pass owning pointer here. I could just pass reference. Let me test something in the TTS.
Mouthful says,
Is the TTS working?
Okay, it does. Okay. Okay, time to test this out. So let's find a place where I'm using visit children, just one, and let's try to replace it with this approach. Okay, this is going to be perfect. If the rendering is still going to work after this change, then it's a victory. Seems like it's working. Cool. That means the visitor is no longer necessary here. And this parent we can use I here. I is a very good name here because it's not only the mathematical I index, but I like to think about the code from like the first perspective. So if I imagine myself as a widget, which is currently being processed, I refers to myself. So a very convenient accident. Wow, so many things will be simplified now. Okay, the stuff that we have implemented. So this is a bigger refactoring. So the plan would be first to I think then we should probably also be replacing the pointer visit children or something like that. Then it would be nice to switch the widgets themselves. So this is going to be something like a default implementation. I guess it has to be virtual then. And this children view also has to be virtual. Is it even possible? It's not simple, I guess, but let's see. Yo, this is some C++ black magic. Okay, so we introduce a base class. How do we use it? Okay, so the iterator holds a pointer to a polymorphic type. So the iterator itself is... Okay, this is how it could work. Iterator itself is not polymorphic, but the stuff inside is. I think it's going to be possible. Okay, so we are still on the first point of this plan, so it's going to simplify things so much. And stack traces. Stack traces are finally going to be reasonable. Yeah, I do live in Poland. Let's continue replacing stuff. This is going to be an interesting one. Find drop target. This is something that allows us to throw things in the trash. Yeah, we can change this into a proper queue or a stack. So right now it works perfectly. I can grab an object when I cross the boundary. It's about to be thrown out. And then it disappears. Okay, so the baseline is working. The list of changes is clean. Yeah, so let's try it out. Wow, we are kind of combining two totally different things. We are doing transforms and iteration. Anyway. Okay, if we don't want to do this recursively, we need to have a stack. Let's call this queue. Not much. We are starting to transition off the terrible callback hell, and we are switching to iterators. Do the move operation. To kind of avoid some shared pointer allocations. I think I need to keep them as shared pointers to prevent them from disappearing. So this is the pointer positioned in the window coordinates. Yeah, we've been using a lot of tricks here, which we don't need. Let's call this W. I don't think there are many people who would disagree with that. I used to work at a large corporation, so I know how it looked from the other side. So if you are in a team, like a team that manages a large product, something like the team within Microsoft that's managing Windows, their perspective on this looks different. So they are looking at statistics about how their product is being used. And they, for instance, see that very few people turn on, I don't know, security features, or that people use their computer day to day, and very few people actually care about administering their PC, like tweaking settings, making sure everything's smooth, updating stuff. So the people within Microsoft, I guess, they see themselves as a sort of like a default technical support for the average user. So they probably ask themselves, okay, would the average user want something? And if they think the answer is true, and they actually check this by doing surveys and experiments, then they flip the switch. So I can imagine how it looked from the other side. Copilot is though the Windows Copilot, because Copilot refers to 10 different things. The Windows Copilot is not really kind of implemented. Any local application can now get access to your history of using your computer. It's not that it was impossible, because any application can record your desktop. It's just possible on Windows. But now it's a little bit easier. It's a little bit harder to catch when, for example, a piece of malware, that can access the archive of the screenshots of your PC. Before, the malware actually had to be executing, it had to be doing the screenshots itself. Now it has this like repository laying around. It depends. If I remember correctly, Copilot doesn't actually upload the screenshots. They are stored locally. So technically speaking, it's not spyware. It's just aggregating your user history, and it needs to be very clear where it is. You know, whenever you, for example, clear history from a browser, it will usually skip, you know, the system history now. It needs to be very visible to the user that this history is there. Yeah, it does. It makes it a little bit easier for actual spyware to extract data. Okay, I'm not so convinced that it's, you know, purely... It's definitely... It could have been implemented better. The transparency needs to be better in this Copilot. I mean, the user needs to have better tools for managing privacy. They don't have those better tools. So introducing such, like, another place where everything is recorded, it's not so crazy. But those things exist. For example, each browser maintains your full history, like every website you visited, right? So it's not that different. And there are good uses for this kind of information. So it's not so purely evil, purely, you know, irresponsible. It's just So what do you think about for example, your browser history? Is there a way to disable browser history so that it's not recorded? I'm not aware of anything, actually. I think this Windows Copilot, they compared how operating system is used to how a browser is used. So if they want to introduce nice features, especially machine learning features, they need some local database to train models on. Those could be local models, but they still need to exist. It still needs to exist to kind of implement those features. AI, like in the sentence that you just said, you said like AI is something more than a tool. It's just a tool. It depends who's using it. If the AI is like doing useful work for you, it runs on your PC, it doesn't leak the data, it's great. That's how this should work. I want to see if the new approach works. It's much simpler than before. No, it does not. Okay, so I have no idea, maybe the order that we are processing the widgets is wrong here. So we are checking first if the widget bounds are infinite. Or if the object has a shape and its shape contains this point. Okay, I see. So the thing is, we first have to search children, and only when we leave the node, when we are exiting the DFS, this is when we should do the check. I wouldn't be so sure. The VPNs are so dodgy. My security advice is actually not to use VPNs. Not to use the subscription-based VPNs, at least. If you can find a hosting provider that you trust, maybe you can set up your own VPN on that host, but something like NordVPN, I would absolutely never use that. Yeah. Or leave a Raspberry Pi somewhere hidden in a mall or somewhere where there is public Wi-Fi and use that as a proxy. I actually don't remember how to do DFS with post order action. This is what I want to have. Post-order traversal using one stack. Yeah. This is a very weird algorithm. Let's read the code. So we have a stack and post order list. Nice. Actually, we can use a recursive algorithm here. Why not? We can use the system stack. So let's get rid of Q. Stalker? No, I never played Stalker. We need an extra argument here. First of all, we don't need this drag location action. Or maybe we do. Okay, first of all, we will iterate over all the widget's children. And if any of them is a suitable drop target, we will return that. Otherwise, Yep. It's possible. It just requires a lot more thought. So whenever you write a code, you just have to record all of the potential values of all variables. You need to know what can happen at any point in code and make sure that you handle all edge cases. Then you can write a completely bug-free code. It's a very slow approach though. And modifying existing code in this way is very hard because you have to first understand exactly what the code is doing. Okay, so this is our new recursive implementation. I'm not like that, come on. I'm just trying to write the code at the same time. Okay. Okay, it looks like everything is working. The new drop target implementation is much easier. So this is the changelog. We removed half the code roughly. here is another place where we are doing visit children. Okay, but this is our wrapper, so this one has to stay. Okay, just 3 more places. Okay, very strange. So we can just change it like that. I'm not sure what this function is supposed to do. It's not working, so the buttons are not changing their color. Maybe I will grab some actual food. So in the meantime, yeah. So here is the timer in my time zone. So see you in half an hour. Okay, I think we'll resume now, but I just noticed that my PC just lost network connection. Sometimes this happens, I have no idea what's happening. So what usually helps is rebooting my machine. So this is what I am going to do. So and there we go, a quick reboot. And I have prepared I have found a video from an interesting channel that we are going to watch now. Once it comes back up. Okay, should be mostly back.
Maybe
So this is the video I wanted to watch, and I have like lunch to eat, so I will mute myself and we will watch this video together.
I don't need to share a screen. If I look okay, if I look sharp enough, we'll see. The one thing I've learned in my life is big fonts. All right. So, what machines want is a provocative title that I enjoyed quite a bit. I kept wanting to stick on a subtitle, something like, how bottom-up engineering will solve all our problems or something like that. But then it just was so much punchier without a subtitle, so I stuck with it. And I think that actually it connects just to what Manfred was saying at the very end, that just moments ago, about it's not about necessarily about our knowledge, but about how we're going to transmit it, how we're going to exchange it. And we need to be thinking much more, much as I hate to say it, this has been a bitter pill for me. We have to be thinking much more like Madison Avenue, much more like jingles and advertisements to make the points true. Sitting down and explaining carefully like a teacher, putting it in some fun way and saying, by the way, you might profit. Now that's the way to get something done. So I'm going to answer the question, what machines want. Machines want space, materials, power, and time. Okay, that's it. So now we can have discussion. Okay. I'm gonna drill. I mean, a lot of what I want to say is crashingly obvious, and yet I feel there are some non-obvious conclusions from all this obvious stuff that says to me someone needs to say the obvious out loud. So that's what I'm trying to do here. So I'll drill into each of these in a minute. Okay, so I wrote this down. Using emergent engineering for integrating complex systems to achieve an equitable society. Okay. Equitable society. I like that. I want to work for that. I don't know, and I've been listening for a day now to what emergent engineering is. And kind of the best I can come up with, really, is, I have a problem with the word emergent in general, because to me, saying something is emergent kind of implies it's over there. It's emerging from over there like that. And, it surprised us, presto changeo, emergence, like that. And I don't feel that that's the way I want to do it. If I'm going to try to get deep inside physical systems, if I'm going to get deep inside manufactured systems and try to understand them on their own terms, really, then I'm going to be over there. It's not going to emerge. It's going to be engineered. It's the other side of it. So we'll see. But certainly keeping the goal in mind of getting to a more equitable society, yeah, absolutely. Okay, let's drill into it. So what I have been working on for about the last a decade or more is called the T2 Tile project. And my goal is to build a whole new computational stack to demonstrate other ways to compute. A lot of folks who I've spoken to, especially folks coming from other disciplines than computation, tend to have a very narrow view of computation, like CPU and RAM and deterministic execution. That's what computation is. And that's partly computer science's fault. Computer science has gone and said that sort of thing, that if you don't have, step by step, one thing at a time, if it's not guaranteed 100% reliable, it's not computation at all. But that's a completely unsatisfactory characterization of computation. It's far too narrow. There's so many more things beyond CPU and RAM. And so the questions I addressed was, well, if the architecture of computation is not going to be CPU and RAM, what is it going to be? What should we be going for if it's not a faster CPU and a bigger RAM? And the suggestion is we should be going for indefinitely scalable systems. And so the way you build an indefinitely scalable computational system is you settle on a tile. And this is the tile that I settled on, I call it the T2 tile. It's got a tiny little Linux box inside, and it connects to others of its own kind in any of 6 sides. So you can build this two-dimensional wall of these things. And in fact, we have a wall that I'll show an example in a minute. These things are not deterministic. There's no overall synchronization among these things. They race with each other. Some of them, will reboot, while the rest of the system doesn't, and the software is supposed to deal with all of that. So if not CPU and RAM, what? Pick a model that we can grow arbitrarily and understand the properties of that. And that's what the T2 Tile project is doing. And again, if we don't have deterministic execution, because my claim is deterministic execution is a property of small systems. And so if you're going to say seriously anything about scaling, you have to be ready to move beyond deterministic execution. You're going to have to say what happens in failures simple and complex. And the fact that we don't say that is one of the poster children for why we have unintended consequences. And it happens over and over and over, and it gets incredibly old when we're looking at it from a bottom up. We build the system to be robust first, and we'll take out a whole huge category of unintended consequences. There'll be plenty more. If not top-down control, well, then what? And the answer I'm going to give is the idea of delegating agency, that we're going to say, a component of this system, you are going to get to take care of this little bit of space, this little bit of time, this little bit of energy. That's yours. Keep it clean, keep your desk clean, try to be ready, help out the neighbors if you can. And we're not going to worry about it anymore. That's how we're going to get past the idea of traditional engineering that's trying to control all the elements of the system. They're trying not to delegate any agency and hold it all at the top, which is, again, fine for small systems and a disaster for systems at scale. And so a lot of what's going on in our world is that we have these disastrous, stupid models that don't work at the scale we're applying them, and therefore they're getting exploited for money by people who get it, and the rest of us are getting the hoodwinks pulled over our eyes. And so what I want to do now, yikes, is show a little clip for a couple of minutes of the kinds of things we've been building over the years with the T2 tiles to get a little bit of the flavor. So, these tiles have no synchronization. So even to get them to do something like turn off, that requires all kinds of communication and scheduling. And you see in a second how this turns off. It doesn't go bloop. Everything is operating on its own. There's no strict step-by-step, and sometimes it doesn't. So we've got a cellular automata where the edge of the cellular automata is some kind of completely irregular shape, and in fact it may change while the computation is running. So this is called splits at the end of the universe. It's a particle that just goes until there's nothing there, and then it makes two of them, and off it goes. And over the years, started doing experiments trying to build systems that would make small structured scale, spatially structured systems. There's no absolute coordinates here. There's no 0, 0, 1, 2, none of that. And yet we start to build these things. And so the idea of doing these plates, little 2D things, is let's make a finite synchronization zone, a little zone that we're going to say here we have a XY coordinate within the plate, but not between the plates. And then we can have these things go. So now we actually have sort of a developmental program, make the right eye, make the mouth, make the left eye, which is kind of a stupid way to do it, but what the hell, and so on. Now, I'm including this one. This is another version of splits at the end of the universe that we saw a minute ago. It's a color one, but this happens. And this is a serious bug in the event processing engine that's running under this thing. This is, I learned of it. And what amazes me, and this goes on for a long time, is that the system actually recovered from it, even though the individual cells were crashing all over the place and trying to restart. And now finally, sort of to wrap up, taking the idea of, again, a local coordinate space, and in this case, it's a diamond, so it's like Manhattan distance of a circle, and develop ways for them to move and sense until I could make this. I could make a, I want to say, living cell. It's got a cell membrane. It's got these kind of like cilia that serve to give sensors so that the cell can get earlier warning about when it's running into something, because it takes a long time for the information to get from the edge to the center, and that's where it has to make the decision on which way to go. And now we've got these things. This is actually a program for a two-cell creature that forms a forward slash made out of two cells, and additionally, yeah, and you can see them. You can see it forming there, as well as spinning off an extra cell so that eventually it'll fill the space with forward slashes if all goes well. And none of this happens the same way every time. Getting this to happen, it was a big deal. It's not easy. And the last thing that we're doing this year is using the T2 tile matrix as a controller for a simulated vehicle. So here it's assigned the job of getting rid of all the yellow balls, and it does that with great exuberance. That's it. Okay, great. So, what that says to me in my 9 remaining minutes is scaling is not a single activity. It's not like you have n and you just increase n and then something magic happens in the world. That's not scaling, or that's a very naive notion of scaling. And what we actually need is to have scaling that creates structure at all scales. So when we have, one of these tiles, for example, consists of about 500 individual little cellular automata sites. It's a collection. Each cellular automata site consists of 96 bits. Each tile connects to 6 other tiles, and so forth. Structure at all scales, rather than the naive idea, the Facebook idea, the idea of every internet play that we will control everything from the center. Which is, again, the traditional engineering approach, and the approach that is a disaster. Okay? All right. So, quickly. Machines want space, material, power, and time. Machines want space. What does that mean to me? Well, for one thing, it means a machine would rather be, like compact. It would rather actually, fit all inside a square yard or a cubic yard or something like that, a sewing machine in a box, rather than have a piece here, a piece there, a piece all over the place, and so on. Machines want space, so mise en place, right? That the way a machine is happy when everything it needs is right where it is, close by, so everything can be grabbed and so forth. The deep, deep point is the first one. Machines want a stake in the universe. Machines have to exist. That's their purpose. They can't do anything if they're just an idea. They can't do anything if they're just words. The words have to be executed by something, and that something has to exist in the physical universe. And so we are these weird programmable machines. People are programmable machines. That seems pretty unarguable to me. There's many ways that we can look at people, but one of them is, on the one hand, we've got this meat, and on the other hand, we've got all this language that can change our behavior. And so when we talk about, as Manfred did and as Jeff did, talking about the difference between social and physical, the difference between traditional engineering and maybe emergent engineering, I think the clearest way to express that is talking about hardware versus talking about software. And the reason that it's important to understand that software is physical too. Software takes up space. Software sits in memory, sits on a disk, sits in a flash drive, and when software is in some spot, nothing else can be stored there. So it's not a matter of being physical or not physical. It's all physical. The difference is that code is so cheap to move. It's so cheap to copy that we get completely different statistics in what we look at out in the world. When something can be motivated by code, boom, that's what it means, can go viral, that kind of thing. Now, of course, viral is actually carrying physical matter, but that's optimized the thing down so the whole thing is about as big as it needs to be the code, and therefore it's a touch point between the physical and the social. So, a machine wants space because it has to exist in the universe. And when we are being abstract, like the laws of physics do not care where you are. That's their signal characteristic. That's the whole thing. We're trying to find out the stuff that doesn't matter where you are. This is stuff that's true everywhere. Physical law is isotropic, like that. Which is great, which is wonderful, but that means it doesn't address the reality of having a stake in the universe and wanting to preserve your stake in the universe. That's what we have to be aware of. So, machines want material. Now, material is not the same as matter, and this is what Nicholas was talking about yesterday, about blueprints. Because a material is matter plus code. It's matter plus warranty, matter plus a name, matter plus implicit fitness for purpose, whatever it is. And in fact, building machinery based on a blueprint, which is based on a program, a blueprint is a program, all machines are this parallel walk of physical stuff and code stuff. And if the material, and just as he talked about, we have to melt the aluminum all the way down to bare aluminum and cast it back up again so that we can make a sheet that will pass for aluminum new. And the question yesterday was, is there a way that we could reuse at higher level? And the answer is sure. If we had structure at a higher level. For example, if we built everything out of Legos, then we could just break them down into Legos and then build them back up. We don't have to go all the way down to plastic, to butyrene, and so on. Okay. Machines want power. Okay. The important point is that machines require a source of power because machines do actual work. Even if that actual work is just lighting up an LED or pushing one bit through a wire or whatever it happens to be, that's still work in the physical sense. It still takes energy. And so we have to have that all hooked up. The machine won't run without power. Machines want time. That's the fourth and final thing that a machine wants. And it wants time because it takes time to do all of this stuff. It takes time to do construction. It takes time to do operation and so forth. Okay, I'm almost out of time. Now, as a second order effect, after we've understood, yeah, machines want space and time, they want materials and power, what machines also want, machines want work. Machines want profit, they want stability, and they want allies. And this is pretty clear, right? Because how is a machine going to stay in the world if it's not turning a profit? How is it going to pay for its, oil jobs and so on and so forth? And machines need to connect to other machines. That's how we get compositionality. That's how we build bigger machines out of smaller machines. We make contracts. We make allies. And just like a contract, literal East Coast code, the code of the legal system describing the obligations of a contract, there's exactly the same sort of thing going on where there's a physical relationship about I give you money and you give me aluminum, and then there's a contractual relationship that goes with them, and both of that is necessary for the system to turn the crank and for it to all work and produce a new machine, whatever it's supposed to do, like that. So that's how we're going to scale up. We're going to scale up. We're going to build machines that want to have local agency. They have space that they control. I have this space right here. This is all mine. I will defend that if you try to get in here. And in fact, what Chris was talking about the deliberative democracy stuff, what's different about actually gathering in a room and having quiet discussions versus, being here like I am on the internet? And, one difference is in one case you're in punching distance, and the other case you're not. And that is just another example of the primacy of space. And so I want to end by saying we're trying to build new abstractions here that do not start by throwing away space. So traditional physics starts by throwing away space and saying we're only interested in stuff that's true everywhere. And instead, the engineering is to say, we are interested in stuff that's actually situated in some particular place, and it makes these kind of relationships with its spatially close neighbors, and it makes those kind of relationships, and so on and so forth. Once we get beyond determinism, what does it mean to make allies? What does it mean to make contracts? And in the bigger picture, it's not, small talk with messages and responses. Well, it is kind of, but it's so fluid. It's so flexible. It's so non-deterministic that, phase lock loops in electrical circuits are absolutely basic thing, essential for communication, so all kinds of things, clocks, you name it. I want to say there's a obvious generalization of phase lock loop to much more complicated systems, like us having a conversation back and forth, taking turns, sending text messages, whatever that is. That is a phase lock loop in a distributed system that we have just fallen into and created for the purpose of communicating about dinner or whatever it happens to be. Okay, I'm over my time, so I'll stop there. I hope some of this was interesting. Thanks anyway.
That was really nice. So Dave talks at a very high abstraction level. It may be hard to... He does this because it's more... it's easier to catch attention this way. He's looking at something very important, which is neglected in software engineering, which is about caring about the physical reality where software runs. And I think a lot of those ideas that he proposes, they are fairly obvious. Like, those are things that should really guide how hardware is being designed. But the benefits of those ideas, I think they mostly manifest at very very short timescales, or at the edges of what is possible, with engineering. So a microchip may need to care about physical distances between components, between subsystems of the chip, because the distance matters there, because at a high enough frequency you just get errors if the line is too long. At human scales we don't see this. His computer T2, it's a fun computer. I think it would be actually practical if it was miniaturized to something that can run like an accelerator card, right? We have GPUs. We could have, quantum accelerators in the future. We can have neural accelerators. I think a grid-based computer would also make sense in a PC. Like DSPs, we also have DSPs. Some of computation is very natural in this grid-based sense. It's very power efficient. What he says about control and centralization of control, I'm not sure I agree yet. I may be convinced. I think control is still a lot easier to do if you can centralize stuff. Even in this grid-based system, flashing a program, it requires probably some very specific firmware so that, when you install a new program on the edge of the computer, that it actually propagates to the whole of the system. But yeah, a 2D computer or a 3D computer, that would be extremely efficient, I think. Maybe not thermally, or maybe thermally as well, if you design it properly. It's like a solid architecture for a supercomputer or a very highly efficient chip. Yeah. I really love this. I am a big supporter of the T2 project. Okay, let's get back to our code. Actually, can I run cursor? Will this work? Let's do another import of these settings. Oh. I will subscribe, but later. Interesting, I must have messed something with the permissions of VS Code resources. Yeah. Again, import. So let's try restarting cursor now. Oh yeah, this is probably auto-downloaded update. But I don't see the background here. Retry. I'm afraid custom background doesn't work in Cursor. I will figure this out, maybe... Okay, so since we don't have any cursor model, let's just run regular VS Code. Maybe tomorrow I will take a look at that, because I got used to the backgrounds too much now to get rid of them. They are just too nice to have. What is the issue? I am doing exactly the same thing. FG. Okay, maybe if I change the color, maybe then I should return phase animating. Let me copy this and temporarily let's revert this change. Let's revert everything. Yes, discard. The recording seems to work, the playback seems to work. Now let's comment this out and insert our replacement. And suddenly it stopped filling itself. What is the change? And now it works, okay. What's up with that? Is this a Schrodinger's bug? It disappears when you log it? Seems it's working fine. I have absolutely no idea. Let's change this very slowly. Let's remove the log import, because this is the only change. There seems to be something off. About those colors. Okay, let's remove control flow now. It was being marked as unused, but I have no idea. Like a minute ago it was not working. Now I'm even afraid to remove comments, because sometimes there are issues like that, where presence of a comment in the code actually changes its behavior. This is strange. Now this one has a recording button active. And now the timeline didn't update. Huh. We're probably missing some invalidate call somewhere. This is just weird, the stuff that just happened. Okay, so I have an object, timeline with this red button. What happened there? What was that? And now it updates instantly. Some strange things are happening. Okay. That was a nice change. We removed a couple of unnecessary lines. And the stack traces will be nicer now. Do we have any other visit children? We do. Here. here. You know what, I will mark this as const, but here I will cast away constness, because I just don't want to deal with this. And this is going to be interesting. When we draw children, or when we draw the background, we draw this in reverse order. I actually wonder why doesn't this work. So children should hold a vector with references. Okay, so we need a random access iterator. We can do that, I think. Jesus. This is a complex thing. Okay, so we need to implement those operations. I think our end iterator is going to become a regular. Iterator, but with a different eye. So we need to add this plus exactly minus equals okay, we also need the this square bracket operator. It's still not passing, right? Maybe if we try to compile it, it's going to tell us what's the issue. Okay, children view needs to satisfy view. Okay, let's derive from this. Okay, it needs to satisfy the range. But we do have the begin function here. Sorry, not here. Here. I have another idea. Suddenly it works. And we don't need any of that. Crazy. Is this going to work? Seems it does. I wonder if this is going to work. It seems to work. Shouldn't we have a... This should be a segmentation fault, right? It's not. I can also do that. I'm just glad it works. I like that we are removing code. A couple lines here, a couple lines here. Okay, the last one. Okay, this is only used in one place here.
Low pass effect.
Okay, this is actually used in a couple of places. Because we are drawing tracks here and other widgets afterwards. So I think I will not delete this function yet. I think it's okay. I wonder whether I should call the other function or not. Probably not. Okay, we removed almost all instances of visit children where it's actually used. Or maybe we didn't. We didn't, and there is some more still. So a lot of them are implementations. But we also have this. Okay, those are the two last ones. Let's take care of them. This is super easy. I think I'm not using this GUI align. Oh, why is this button red? So strange. Anyway. Interesting. The button is a very specific class. So this is a short circuiting for the final cases where the button is fully filled. We will only draw one of those children. And this is the part where we do the clipping. There should be a way for the parent widget to say that the child should not receive events. I'm not sure if this should be a function. Maybe function is better. I think function is better here. We don't have to care about state updates if we have a function. But it shouldn't look like that. It should not be called pointer visit children. So I think this should return all of the children. And then we will... Okay, we have two options. Either we have a dedicated function which returns only children which are reactive to mouse. Something like pointer children. Or we could have a flag that we will pass into this function that will say the context for the subset of the children that we are asking for. Or we could pass nothing and then we could filter the children that we are not interested in. I think the last one is the best. This. Let's remove this function completely. All of those files. This is where we will have to fix everything. Let's start from here. Headers, we need to fix all of the header issues. Key presser. What's the issue in base? Okay, that fixed almost everything. Now just pointer CC. Yeah, this DFS. Let's do regular visit children right now. And here's where we'll do the skipping. I hope this will work. I think we might have missed this, but we will see. Yep. I think using parent here, it's not always the case. It's not always possible. Not all widgets have parents. I have no idea why it didn't work, then started to work. Let's get rid of that. So strange. Okay, I think it's working. Now I want to do a very strange change, given what I have done right now. Instead of block, I will change this to allow. It's easier to read. Looks good. Now we can get rid of these visit children. Literally in the last place where we still use it. And this is going to be tricky. So maybe let's first submit everything we've done so far. I think we can make a queue based. Or can we? Okay, this point and transformed, we will do this completely differently. We now have a much better function, transform down. So I could use system stack. I'm not sure if system stack is... I use this a lot. I should just figure out how to use the DFS to do post order. Actually, I had a book with that. Let me find this. I have to search for something in this book. Give me a sec. Actually, it seems like the path, this is a very important array for us. Need this point. Maybe I shouldn't use shared pointers. Honestly, I'm not sure. When we will be introducing multi-threading, it may get messy, so it's good to keep references if we can. Path is actually a list of weak pointers. Because the widgets can be deleted, yeah, and the path needs to capture that. It needs to still work. Anyway. Can do those, sure. Come on. I could do some things with checking parents, but I don't think this is the way to do it. Okay, so I think this, we don't really need to care about this. I mean, I don't want regular, so I don't want to abuse this stack to traverse widget hierarchy. I think all those traversals should use queues. And like manually managed stacks, heap-based stacks. So if a given shape contains the pointer, then we should push it on the stack. So this is the standard DFS. Stack of iterators. think after we push all of the children, we will push the widget again. So this is one trick to get post ordering numbers. It's not super clean though. I would curse myself if I read this code in a week. Okay, we could also move this check here. And there is a subtle difference here. Oh, come on. Why does it have to be so hard? see. We need shape. Fill path is a bad name. Maybe it should be... This is actually what it does, but... It's not obvious how to convert this into a regular DFS with manual stack. Actually, this section is identical here. Let's maybe combine them. Okay, so one thing we can definitely say is that the final element of the path always is like that. Actually, I could forget about those path pushback and pullback. I could use parent chain to reconstruct the path. whenever we return true, we are essentially unwinding the whole stack. So this is the innermost widget which has a shape, and the shape contains the pointer. Maybe I could change this logic a little bit. I'm not sure why it's exactly like that, so I will keep it unchanged. Nice. Check that out. There are no more visit children. I mean, there is just this one here. Okay, so the last to do here we will do during the next stream, and this will be the end of. So this is actually the first code cleanup, like actual code cleanup that we planned and we are implementing now. I would like each widget to hold this array itself. So we'll have to find all of them, all of those, all of them. And we will have to fix those. Oh look, there was a to-do here, to do exactly that. We did fix this today. This is still to do. Still to do. Still to do. And this is the current task that we're doing. I completely forgot about this to-do list. It's a reasonable list, actually. Lots of cleanups. I may actually look at this tomorrow. I will see. Okay, so for tonight, that's it. See you on Wednesday. Bye-bye.